So with this problem, we're asked to graph a quadratic f of x equals negative 3x squared plus 2x minus 12 using its properties. And that means its axis of symmetry, the vertex, y-intercept, if it exists, x-intercepts, if they exist, and then other points possibly based on symmetry, which is what the axis of symmetry means. If you have a point on one side of the axis of symmetry, you have a point on the graph in the same location on the opposite side of the axis of symmetry. So since A is negative 3, we know that the graph opens down. The axis of symmetry is x equals negative b over 2a, which equals negative 2 over 2 times negative 3, which equals 1/3. So we know that there is an axis of symmetry that is the vertical line x equals 1/3. So now we use that to find the vertex. We find f of 1/3, which equals negative 3 times 1/3 squared plus 2 times 1/3 minus 12. Simplifying that, we get that equals negative 3 times 1/9 plus 2/3 minus 12, which is negative 35/3. So our vertex is at 1/3, negative 35/3. We'll go ahead and plot that point, and using a scale of 2, otherwise we wouldn't be able to fit it on this graph. Because negative 35/3, that's over 11. So we go to 1/3, negative 35/3, which is right about here. And we graph our vertex. And again, that's also where our axis of symmetry is. That's where the vertical line x equals 1/3 comes into play. So now we'll look at x-intercepts. That's where y equals 0. So b squared minus 4ac equals 2 squared minus 4 times negative 3 times negative 12. That equals negative 140. So that means there aren't going to be any x-intercepts because the determinant is negative, and therefore there are no x-intercepts. Y-intercept is when x equals 0. So we find f of 0. F of 0 equals negative 3 times 0 squared plus 2 times 0. Minus 12, which equals negative 12. So we have a y-intercept at 0, negative 12. We'll plot that point. And we know it's opening down. And then using the axis of symmetry, we know that there's a point on the other side of that as well. So we're going to have a point on the same spot on the opposite side, which is going to be of the axis of symmetry, which is going to be 2/3, negative 12. And then we can plot a couple more points just to, fill in the space in order to get the entire shape that we need. So let's go ahead and use x equals negative 1. F of negative 1 equals negative 3 times negative 1 squared plus 2 times negative 1, which is negative 2, minus 12. So that's negative 17. So we have a point at negative 1, negative 17. And again, we know that because of the axis of symmetry, there's going to be a point on the opposite side as well. But we'll go ahead and just plot another point, at x equals 1, f of 1 equals negative 3 times 1 squared, which is just 1, plus 2 times 1 minus 12. That equals negative 3 plus 2 minus 12, which equals negative 13. So we know there's a point at 1, negative 13. And then we can put this all together. We'll go ahead and plot the points according to symmetry. And then we can go ahead and just connect the dots to graph the quadratic using its properties. So again, using properties to graph a quadratic, we find the axis of symmetry, then the vertex, determine if there are any x-intercepts. In this case, the vertex was already below the x-axis, and we know it opens down. So we really didn't need to find the value of the discriminant, but we did to verify that there are no x-intercepts. We find the y-intercept, and then we find the point of symmetry on the other side of the axis of symmetry from the y-intercept, and then we plot a few more points and the points that are determined by the axis of symmetry from those points on the opposite side of the axis of symmetry, and then connect the dots and indicate in behavior with arrows to complete graphing the quadratic.